In this video, what we're going to be talking about are relations. Relations. When we talk about relations in a math class, we're just talking about a set of ordered pairs. Now that set can be given to you in a number of different ways. It can be given to you as a list or a diagram. It can be finite, it can be infinite. It can be given to you as a sketch. Oops, I want to give away my secrets. If we have a finite set, maybe one that just has 2 or 3 points in it, we can just make a list, like we did back at the beginning of the semester when we were talking about sets of numbers. We used the squiggly brackets to designate our set, and we can just list the items that are in there. Okay, if this set were to go on forever, it would have to have some sort of pattern where we could write 2 or 3 or 4 items and then put ... But maybe I just have the set that has 3 points in it. 2, 3, 1, 4, and 0, 5. Instead of a list, maybe I have some sort of diagram that indicates what numbers are paired together. So the blob on the left are my x values and the one on the right are my y's. And maybe x is either 1 or 2, and maybe my y value is 3, and I use arrows to indicate how the numbers are paired together. So one ordered pair in this set is the ordered pair 1, 3. The other one is 2, 3. Maybe my set is given to me as a table. Maybe I have the points 5, 3, 5, 4, 5, 5, 5, 6. And again, it's like a list. Here I have an actual list. Here I have a picture that tells me what my points are, and down here I have a table that pairs up my values. Maybe my set, instead of being finite, maybe it's an infinite set. Maybe I'm given an equation. Okay. Now, depending on where we are in the class, we may or may not know what that looks like. So I'm going to draw a picture and say y equals 2x plus 3 is a straight line that looks similar to that. Just having an equation in front of you is not always enough information, at least at this level of where we are in the class, for students to be able to understand the different pieces and parts that we're going to move on and talk about in a few minutes. So if I'm not given some sort of list or diagram, I would like to see a picture of what I'm working with. Now understand that these two blue graphs that I have drawn, these are infinite sets. Infinite meaning I can't make a list of all the points, not even 2 or 3 of them, and put ... But any place that I want to stand on this line has an address, an ordered pair address. And same thing with this circle. No matter where I stand on the circle, all of those points have an address. I'm going to go ahead and put the axes in here. If I can draw my lines straight enough. Hey, that's not awful. Didn't do what I wanted, but that's okay. So maybe I have a list for my relation. Maybe I have a picture or an equation. If I have an equation, again, right now, looking at a picture is still going to be our best approach. So I'm going to need to have someone help me get that drawn. Okay, or maybe I just have my picture there. Okay, any equation that you want to make up, any picture that you want to draw, any table or list that you want to make, all of those things are relations. Now, every relation has 2 parts to it. It has the domain and it has the range. And we may or may not have talked about either of these phrases in the class at this time, again, depending on which class you're in with me right now. And so we'll just either remind you or let you know that the domain is the set of x values that are used in our relation. Okay, the domain is the set of x values. So if we are looking at any of these relations here, maybe we'll go green for the domain. if I'm asked to give the domain of any of these 5 relations, we will, for the first 3, just make a list. If we have a list, we make a list. So if I look at the top left relation here, and I look at the x values that are used, it looks like I use the values 2, 1, and 0. You can write those values down in any order that you want, smallest to largest, the order that they're listed, however your favorite order goes. It's free game, or fair game to write them down in that order. If we're looking at the top right corner, that relation has x values of 1 and 2. So we'll write both of those down. And in the bottom left corner, it looks like the only value that's used is the number 5. Now, if a value is repeated, meaning I have 5, 5, 5, 5 here, we're only going to put it on our list one time. Okay, same thing, regardless of how the relation is presented to me. If there's repetition, we're just going to write it down once. Now, when it comes to the domain of either of these 2 relations, we're going to use interval notation instead of making a list. When there's an infinite number of numbers covered, there's not a good way, there's not a correct way that we can make a list of all of the values of x that are covered here. And so if I want to figure out what values of x have been used, I think about walking. I know the x-axis is this axis here, the horizontal axis, and that has to do with left and right movement on my graph. So I think about walking on this line to its farthest left point. Okay, it does not matter how high or how low this graph goes. I'm just worried about how far to the left that it goes. Since it continues on and the arrow indicates it never stops, the left side of the graph touches negative infinity, which isn't really isn't a place, okay, but it just continues on forever. If I follow it to the right forever, it continues on and on and on and never stops. So that means it approaches infinity. Remember, with infinity and negative infinity, we always use parentheses. If we come over to the circle, okay, my scale here isn't super good, but I'm going to try to put my lines in where I meant for them to be. Okay. If we follow our graph to the left as far as it goes, notice this one does not continue to negative infinity, but its farthest left point is negative 1. Because it actually touches negative 1, here's negative 1 comma 0, but it's negative 1 comma something, then negative 1 is included in that set. If we follow this circle to the right forever, okay, it looks like the biggest number that it touches is 3. And because it does, in fact, touch the number 3, we're going to put square brackets around the 3 there. Okay, interval notation indicates that it touches everything in between. So here's a point that's at negative 0.9, negative 0.8, negative 0.234. Here's positive 1.23456. Here's 2.89. Okay, everything between negative 1 and positive 3 is touched. Okay, now, a lot of students are worried about the axis, and they're focused here. All our focus should be on is left and right, meaning if I slide this circle, now I can't find it again, slide this circle straight up to here, its domain would still be negative 1 to positive 3, assuming those blue dots down below aren't really there. Okay, if I slide it down here, it moves to the left to negative 1 and to the right to positive 3 and touches everything in between. So domain is the set of x values. If the domain is the set of x values, then the range, go back to black, that's going to be our set of y values. Okay. When we're determining the range of a relation, we're going to do the same thing that we did with the domain, only now we're focused on the y coordinates instead of the x. Okay. So here, if I look at my list, I make a list, And it looks like my range is 3, 4, and 5, in whatever order you want to write them down. Okay. Now my video is getting kind of long and I don't want to have to trim anything, so here in just a moment I want you to go ahead and pause the video and try to write down the range for these next two, just the next two. When you turn it back on, that's what will be there. Okay, so the range, I have a list and I make a list. When we're writing the range of the line or of the circle, we're still going to use interval notation, which means the smaller number, comma, the larger. Okay, with the domain, that was the left end of the graph, comma, the right. When we're looking in the y direction, y has to do with up and down, so it will be the bottom of the graph, comma, the top. The bottom of the graph, comma, the top. Go ahead and pause the video in a moment and write down what you believe the range is for these two graphs. And when you turn it back on, both of the ranges will be there. So go ahead and pause. The bottom, this line continues down forever. It does not stop. Same with going up forever. So all real numbers is the range. Over here, bottom of the graph is -2, the top is -2, and again, it actually touches both of those values, so we'll put them in square brackets. The next video will go on and talk about another topic, but I'm going to use these same graphs.